Hello everyone. Welcome to Daily Does of Space. Space just delivered 3 major discoveries at once. A strange new material found on Europa, an alien world barely bigger than our moon, but somehow holding on to an atmosphere, and brand new images from the Perseverance rover, revealing rocks that should not exist where they were found. So, today, we're diving into Europa's exotic quantum ice, the smallest planet with a real atmosphere and a Martian puzzle that hints at ancient hydrothermal systems. Let's get into it. JWST detects quantum salt ice on Europa. Europa, one of Jupiter's icy moons, just became weirder. Using the James Webb Space Telescope, scientists detected a type of salt that doesn't behave like normal salt. In fact, it behaves in a way that only appears in materials with quantum scale properties, something like a quantum salt ice. This material appears on Europa's surface where the ice is fractured, the same areas where subsurface ocean water likely leaks upward and freezes. And here's why scientists are excited. This weird crystalline salt can only form under extreme pressure and extremely cold conditions, exactly what exists in the ocean beneath Europa's ice shell. In other words, this material is a fingerprint of a deep global ocean interacting with the surface. And if that's happening, it means Europa's ocean is not sealed away forever. It might exchange chemicals with the surface, just like Earth's oceans interact with hydrothermal vents. Why does that matter? Because that's exactly the environment where life on Earth may have started. Webb didn't just confirm the existence of the salt, it measured its spectral signature, compared it to known lab tests, and confirmed that Europa isn't coated in simple sodium chloride. It's covered in a complex mixture of salts that may include magnesium and sulfur compounds shaped by pressure, cold, and possibly biology. This doesn't prove life, of course, but it strongly suggests Europa's ocean is active, not stagnant. Something is pushing ocean water up through the cracks. And that means Europa is moving up the list of places where microbial life could exist today. A tiny planet with a real atmosphere. Next discovery. Astronomers have confirmed the smallest exoplanet known to hold a stable atmosphere. The planet is GJ1132b, a rocky world only slightly larger than Mars, far too small for scientists to expect an atmosphere. Normally, stars burn atmospheres away from planets this tiny, but somehow, this one holds on to a thick, surprisingly complex one. It's not breathable. It's made from hydrogen, methane, hydrogen cyanide, and volcanic gases. But this is the astonishing part. The atmosphere appears to be regenerated from inside the planet. Observations suggest intense volcanic activity constantly releases new gases, replacing the atmosphere faster than the star can strip it away. This means the planet may have molten magma under the crust, global volcanic resurfacing, a chemical cycle similar to early Earth, and possibly a secondary atmosphere created after the first one was lost. This discovery matters because it shows something huge. Tiny rocky planets can rebuild atmospheres. And if this is possible around a small star 39 light-years away, then similar planets in the habitable zone could maintain atmospheres long enough for life to form. This is the kind of result that will reshape how scientists think about habitable worlds. Perseverance finds impossible rock textures. Our final discovery brings us back to Mars, where Perseverance just photographed rock patterns that don't belong in Jezero crater. The textures look like hydrothermal deposits, the kind formed when hot, mineral-rich water flows through rock and cools. On Earth, these environments are oasis zones for microbial life. But here's the problem. Jezero was believed to be cold, sedimentary, and lacking volcanic heat. Yet the rover found rounded silica nodules, layered microfractures, mineral coatings that require flowing warm water, and even mineralogy, suggesting past hydrothermal alteration. If this interpretation holds up, it means Jezero crater once had warm, chemically active groundwater, not just a cold lake. This changes everything, because hydrothermal systems concentrate minerals, create chemical gradients, and support microbes extremely well. And this means Mars may have had two environments for life, not one. A surface lake and a warm subsurface circulation system. The rover will not analyze these samples fully on Mars. We will need Mars sample return to bring these rocks back to Earth, which is currently being redesigned after budget issues. But make no mistake, these are the most promising samples ever collected on another planet. Europa may be venting ocean material, small rocky worlds may rebuild their atmospheres, and Mars may have once hosted warm, life-friendly hydrothermal systems. If space is trying to tell us something, it's this. Life might not be rare. It might just need a place to hide. If you want daily deep space discoveries and mysteries like this, subscribe for your daily dose of space.